lecture series on permutations and combinations. In this lecture series, we will systematically review the definitions of permutations, combinations, and look at several example problems which you can face in an exam based on permutations and combinations. So the basic result in permutations and combinations is the following fundamental result. It is called the fundamental counting principle. And it can be stated as follows. Suppose you have event E1 which can occur in W1 ways, and suppose you have event E2 which can occur in W2 ways, and so on until event EP which can occur in WP ways. So for instance, event E1 can be the number of ways in which team A in a sports tournament can win the tournament, and event E2 can be the number of ways in which team B in a totally different sport can win the number of ways in which it can win the tournament, and so on. We assume that events E1, E2, and so on to EP are mutually independent. And what this means is the number of ways in which event E1 can occur is independent of the number of ways in which events E2 to EP can occur, and the number of ways in which event E2 can occur is independent from the number of ways in which events E1 till EP excluding E2 can occur, and so on. So they don't affect each other. So then the total number of ways in which E1, E2, and so on till EP can jointly occur is given by W1 times W2 and so on till WP. And the shorthand for this can be written as product of all Wj's, j equal to 1 to P. So if you have P mutually independent events and you know the number of ways in which each of these mutually independent events can occur, then the total number of ways in which the events can jointly occur can be given by this product Wj. So let's see an example application of this result. The first example we shall see is we want to find the number of ways of arranging three distinct objects. So the example asks you to evaluate the number of ways of arranging three distinct objects. So just to illustrate this example, let's call the three objects to be A, B, and C. And these are your three objects. So to find the number of ways of arranging these three distinct objects A, B, and C, and when we mean arranging, we mean arranging in a row. So we can work this example out by hand since the number of objects is small. And so suppose you have three places in a row where you want to arrange these three objects. You could have the arrangements A, B, C. You could have the arrangements A, C, B. You could have the arrangement BAC, you could have the arrangement BCA, you could have the arrangement CAB, and you could have the arrangement CBE. So note that there are 6 different ways in which you can arrange 3 distinct objects, and the 6 different ways are listed here. So a way to arrive at this result without enumerating all the different ways in which these objects can occur can be arrived at follows using the fundamental counting principle. So since we have 3 different spots to place the objects A, B, and C, note that in the first place you could have either A or B or C. Okay. So the first place, so far we have not placed any objects in any of the spots, and so in the first spot we have 3 different choices for putting an object in that spot. So you could put either A, B, or C. So once you put either A or B or C in the first spot, irrespective of what object you put in the first spot, the second spot has the options either B or C, or it has the option A or C, or it has the option A or B. So if you put A in the first spot, then you can put B or C in the second spot. If you put B in the first spot, you could put A or C in the second spot. And if you put C in the first spot, you could put A or B in the second spot. So depending on what object you put in the first spot, you have 2 options for putting an object in the second spot. And once you put objects in the first 2 spots, the last spot is automatically determined. Right? You put the last remaining object. So to use the fundamental principle of counting, what you do is you note that there are 3 possibilities for the first spot. You know that there are 2 possibilities for the second spot, and then there's only 1 possibility for the last spot. And the result, and the reason why these 3 events are mutually independent is because even though the object you put in the first spot influences the choices you have in the second and third spot, the number of choices, the number of ways doesn't depend on what object you put in the first spot for the second spot and the third spot. So the total number of ways is 3 times 2 times 1, which is 6. And this 6, or this 3 times 2 times 1, can be simply represented as 3 factorial, which is basically 3 times 2 times 1. In general, n factorial is given by n times n minus 1, and so on till 1 for a natural number n. And this is the number of ways. Of arranging n distinct objects. So in general, if you have n distinct objects and you want to compute the number of ways of arranging these n distinct objects, then the result is nothing but n factorial. In this case, we have 3 factorial, which is 6. And we can simply verify that that is true, since we've listed all the 6 ways in which these 3 distinct objects can be arranged. So let's look at a related example. How many ways are there to arrange three identical objects? So in this example, we have 3 identical objects instead of 3 distinct objects. So suppose we call the object to be A. So now we have 3 objects which are A, and A, and each object is identical to the other objects. So we have 3 objects, A, and A. So notice that we can enumerate the different ways in which we can arrange these 3 objects in a line, and that the only possible way is the arrangement A, because any other arrangement is identical to this arrangement A, since the 3 objects are identical. So in this case, the result turns out to be 1, and this result can be generalized to the case when we have n identical objects and we want to compute the number of ways of arranging n identical objects. So let's look at another example. In this example, we are asked to compute the number of 3-digit numbers that can be formed using the digits 2, 7, and 9. So you can use the digits 2, 7, and 9, and you have to form a 3-digit number. So once again, let's invoke the fundamental counting principle, and we have 3 places in which we have to fill in one of the numbers 2, 7, or 9. So the number of ways in which you can fill the first place is 3, because you can either fill in 2 or 7 or 9, and you will have a valid number based on which number you fill in. The second place has 3 choices again, where you can again fill in 2, 7, and 9, and this is completely independent of the number of ways in which you fill the first position, because you can use the same digit again to make up the number. And similarly, the last place has 3 possibilities where you can fill in 2, 7, or 9, and this is again independent of your choice in filling the first 2 digits. And so the total number of ways is 3q, which is 27. So the number of 3-digit numbers that you can form using the digits 2, 7, and 9 in this case turns out to be 27. So what if we are not allowed to repeat any of the digits in the number? So this is called, in the theory of permutations and combinations, this is usually called without repetition, which means that you're not allowed to use any of the numbers or in general the objects again in your permutation. So in this case we have 3 places again to be filled, and in the first place again you can fill in either 2 or 7 or 9, and you have 3 choices. Now in the second spot you can only use either of the 2 choices which you didn't use for the first spot, and so again there are, depending on what you use to fill the first spot, there are 2 possibilities for the second spot, and depending on what you use for the first and second spot, there's only 1 possibility for the third spot, because you have only one number remaining which you haven't used to fill the first 2 spots. And so this is again nothing but 3 factorial, which is 6. So this example is identical to the first example, because you are asked to construct a 3-digit number using 3 digits without repetition, which is identical to the number of ways in which you can arrange these 3 digits 2, 7, and 9 in a row. So let's look at a final example which uses the fundamental principle in a more nuanced way. And so this asks you to compute the number of 4-digit numbers that can be formed using the digits 3, 5, 7, 8, and 9, and that are greater than 7,800. So you have to form, you have to compute the number of 4-digit numbers that can be formed using these 5 digits in each of the spots, and that are greater than 7,800. So again, you have 4 spots which you need to fill with these digits, but now you have the restriction that the number you form using the 4 spots has to be greater than 7,800. So in my opinion, the easiest way to deal with this problem is to intentionally construct the number. So obviously the first spot cannot have either 3 or 5 because the 4-digit number you construct will be less than 7,800. So the first spot could have 7 or 8 or 9. But notice that if the first spot has 7, then you don't have complete freedom in choosing what the second spot contains because the number has to be necessarily greater than 7,800. So let's deal with the two cases separately. Suppose you fill the first spot with 7. Then the second spot has to contain 8 or 9 since the resulting number has to be greater than 7,800. So second spot has to contain 8 or 9 because of the restriction on the number you can construct. And the third or fourth spots can contain any of 3, 5, 7, 8 or 9 because when the second spot contains 8 or 9 and the first spot contains 7, the resulting number is definitely going to be greater than 7,800. And similarly, the fourth spot can contain these 5 choices. So this first choice, the first set of numbers that you construct where you start off with 7, the number of ways of doing this, write it here, number of ways of doing this is 1, where you have 1 choice for the first spot, and times 2, where you have 2 choices for the second spot, times 5, where you have 5 choices for the third spot, and times 5, where you have 5 choices again for the fourth spot. So if you started off the number with 7, then you have so many choices for constructing the number. Now note that we can also start off with either 8 or 9 for the first spot. And in these cases, irrespective of what numbers you fill in the second, third, and fourth spots, the resulting number is definitely going to be greater than 7,800. And so you can fill the second spot with either 3, 5, 7, 8, or 9. And similarly, the third and fourth spots can be filled with 3, 5, 7, 8, or 9. And so the total number of ways, again, with the fundamental counting principle, is going to be 2 for the first spot times 5 times 5 times 5 for the second, third, and fourth spots. So the total number of ways of total number of 4-digit numbers that can be formed using these digits so that the resulting number is greater than 7,800 is just the sum of these two different ways in which you constructed the number. And this is 50 and this is 250, so the sum comes out to be 300. So there are 300 different ways in which you can construct a 4-digit number using these digits so that the resulting number is greater than 7,800. So this example illustrated a more nuanced case of the application of the fundamental counting principle, and these kinds of examples are usually dealt with on a case-by-case basis, where you have to identify the easiest way of approaching such problems based on what you require, what the rules are in the problem. So that's it for this lecture. Hope you enjoyed watching this lecture on permutations and combinations. In the next lecture, we will look at further ways of permuting and combining different objects. Thank you for your attention.